Okay, so we're gonna start chapter 2, and which is solving linear equations. And lesson 2.1 is gonna be use a general strategy to linear equations. Use a general strategy to linear equations. Now, we're gonna do solving linear equations. First, we're going to start with this, an equation of this form. AX plus B is equal to C, where for all A, B, and C that are elements of the real numbers. And we're going to be using the field properties of algebra that we started in the last video to justify all of the steps we made. And we always going to have a reason for everything. We're not going to say, no, it's just the way it's done. No. So there's always going to be a reason for it. So we're going to start with this equation. And let me give you this example. It says 1/2 of x plus 5 is equal to 11. So is it in the form that we want? We want it to be ax plus b equals to c, right? So we have, here's a, here's b, and here. So a is 1/2, b is 5, and c is 11. Now we're going to translate the equation. It's going to be what? What number, right? What number do I take half of it? Then I add 5 to give us 11. So it's what number do I take half of? Then I add 5 to that will give us 11. Now, be sure, remember that math is like questions. Note that equations in math are like equations in English. The nice thing about math questions is that they all are answered in the same way. We always respond to these questions with, let me show you. So if we have, in English, we will say that number is, right? And in math, we said x is. So that number is this one, right? And is. So we want to find the number that makes this equation true and at the same time answer the questions. We were always going to respond correctly and we will always say x is equal to, like we do it in math, or that number is. So even if we read the question and know the answer, we will solve the equation, okay? I'm sorry, guys. We will solve the equation algebraically. So how do we solve it? I'll tell you how we solve it. We're going to, I'm sorry, guys, hold on. Sorry. So we want to know, we're not looking only at the steps, but the reason behind the steps. So then most of you remember that rule that says what we do on one side, you have to do it on the other side. I will show you how the rule works with the proper justification, and then we go back to our example. Again, we're going to be using the field properties many times throughout the semester to justify our steps. So let's do this. Suppose we have, and I'm going to do it, oh, I could do it here. Suppose we have x equal to 3. It said. So let me give you examples. And we said x equal to 3. So that means that, in other words, is that 3 is equal to, so if we see an x, we're going to be looking at a 3, meaning that 3 is temporarily stored in the variable or the letter. So if I wanted to write the number 3, I can write 3. X is equal to 3. Now, building on this, I can write other numbers using the number 3. I can write other numbers using the first one. So we have 3 plus 1 is 4. Or we could say x plus 1 is 4, right? Because x is equal to 3. We could do 2 times 3 is equal to 6. Or what do we do? 2x is equal to 6. X is equal to 3. Let's do this one. 9 plus 2 is equal to 11. Or, sorry, 3 times x 3 times 3 is 9, plus 2 will be 11. Okay, and the last one will be negative 6 plus negative 2 is equal to negative 8. Okay, so how do we do this one? Negative 2 times what? Times x. This is negative 6. Minus 2 is equal to negative 8. Now, in all of the examples, x is equal to 3, and the value of x does not change. If we look at the first example, let me write it down again. The first example said, the first one, 3 plus 1 is equal to 4, or x plus 1 is equal to 4. And we compare it to knowing that x is equal to 3. I know this. What is the difference between them? So x equals to 3, or x plus 1 equals to 4. What do you guys notice there? That if we add 1 on both sides of the sides, and it does not change the value of x. You see, by adding 1 on both sides, I did not change the value. The value of x is still 3. So notice we have added 1 to both sides, and it did not change the value of x. Okay, let me put it. This part is very important. It did not change the value of x. The value of x is still 3. So here is where we end up with the rule that if you add any number to an equation, you will not change the result, the value of x, as long as you do the addition to both sides of the equation. Okay? And some of you maybe have heard of that. That if you add to an equation, you will not change the result to both sides. Right? Now, let's take the second example, which was the multiplication. And the second one said 2 times 3 was 6, or 2x equals to 6. So let's do the same thing. What's the difference, right? If we multiply both sides by 2. And what happened? If we have multiplied both sides by 2 and did not change the value of x. So let's write that down. Exactly the same. So we have multiplied both sides by 2 and did not change the value of x. The value of x is still 3. And I want to highlight this part. Okay, this is still 3. So we found another rule. That is, we can multiply an equation by any number and it will not change the result as long as we do the multiplication to both sides. So here's the new rule that we found. That we can multiply an equation by any number. And it will not change the results, meaning the value of x, as long as what? As we do the multiplication on both sides. To both sides, okay? Now, let's go back to the original example. Our original example was 1/2 x plus 5 equals to 11, right? 5 the way I believe, oh no, we haven't. Okay. So we're going to apply the inverse elements, which is the additive and the multiplicative, to the equation. And whatever we do, we will make sure it is done to both sides. So now, our goal is to find the number that makes the equation true, right? And remember always that we have to respond that number is or x is equal. So is, okay? Now, I know we wanted to say x equal to, but remember that we could say to, let me write that down. I know we said we wanted the math to say what? X equal to But remember that 1 times x is x, because multiplying by 1 does not change the quantity. Does not change the quantity. And the other one is that 1 times x plus 0 is equal to 1 times x, and that's equal to, hold on, let me write this down bigger here. 1 times x plus 0 is the same as 1 times x. And this is equal to x. Why? Because adding 0 does not change the quantity. Okay? So we're going to compare our original equation to our goal. And we want to make a 1 and make a 0. And that is our goal and a strategy you will see repeated throughout the whole semester. We want to make a, you want to make a 1 and make a 0. You're going to hear me saying make a 1 and make a 0 the whole time, okay? So the exercise that we have says 1/2 x plus 5 is equal to 11, right? And our goal is, so we notice that we have notice that, right? We need to clear out the 1/2 and the 5. So, but we really need to is to bring them down to their identity elements. And here's a question: what field property brings elements down to their identity elements? The inverse element. So let's do it. We're going to identify the operations and the inverse elements that correspond to the operations. So right here, the operation is in the original equation. Right here is multiplication by half. And right here is addition of 5. Now, what are the inverse elements of this? I'm going to try to do it here. That way you guys. 1/2, and I have the inverse. So this one is going to be, the given element is this one, right? And this one is the inverse. So what do I need to do? to make, remember, look at this. I will need to what? Multiply by 2, right? And the other one will be 5 plus needs to be equal to 0. Remember, 1/2 needs to be equal to 1 and 5 needs to be equal to 0. So here's my element, my given element. And this is the inverse element. All right, now, does it matter in which order we will apply the inverse elements to the equation? No, absolutely not. The order doesn't matter. It does not matter. You can make a 1 and you can make a 0 in any order, and I will show you. Now, we should take note that when we apply one element, it may have an effect on or change the other element. All right, so let's do that. So again, the inverse and the inverse. So let's show that that is true, that we can do it in 2 different ways. Let's do the first way. We're gonna make a 1 and then make a 0. Okay, let's do that one first. So I have 1/2 x plus 5 equals to 11, right? So first, I'm going to apply the multiplicative inverse to both sides. So I have 1/2 x plus 5 . Let me use a different color. All right, how about if I 2 and a 2? Okay, so right here, I apply the multiplicative inverse of 1/2. The multiplicative inverse of 1/2 is what? Is 2. Because we know that 1/2 times 2 is going to be 1. And it get us to the identity. It gets to the identity, all right? I applied the multiplication or the multiplicative inverse to both sides. Now that I did that, I'm gonna use the distributive property, right? So it's gonna be 2 times 1/2 x plus 2 times 5 is equal to 2 times 11. So distributive property. All right, so what do I get here? I get a 1 times 11 is 22. And we are halfway to this answer. right? Now, what are we going to do? We're going to apply the additive inverse, which is we're going to have to what? What's the additive? What number will do the, remember this part. It's okay, I'll write it down here. So what number will do the 10 plus what will give me 0? That will be the additive inverse of what? Of negative 10. So we need to add what? Negative 10 to both sides of the equation. So let's do that. Let's go back. So we have the 10, and we're going to add the negative 10 on both sides. There we go. So now we have 1x plus, this is 0, equal to 12, or x equal to 12. All right? And we have our answer. So 12 is the number that makes this true. 12 divided by 2 is 6, plus 5 is 11. It's the only number that makes that true. So we have 1/2, this is 12, plus 5 equals to 11. This is 6 plus 5 is 11. What is really great about this problem is that this type of problem is that we can always check them right away as soon as we finish. So when you take your exams, you should know whether or not you are correct before you click submit, okay? Now, we said we're gonna make it, doesn't matter if you do the make a 0 first or the make a 1. Now we're gonna do it the other way. Okay, we're gonna make a 0 first, and then we're gonna make a 1. And I'm gonna show you that it's exactly the same. So we have 1/2 x plus 5 equal to 11. So let's do, we're gonna make a what? We're gonna make a 0 first, like we said. So we're gonna take 1/2 of x plus 5, and we are going to subtract 5 on both sides. Okay? That's the additive inverse. Five plus 1 will give me 0. And this number is -5. Now, 1/2 plus 5 plus -5. Oops, this is 11. Sorry. So this will be 11 . So what do we get here? 0. So it's 1/2 x plus 0 equals to 6. Now I'm gonna make a 1. How do we make the 1? So I need to multiply this by 2. Times 1/2 plus 2 times 0 equals to what? To 12. So we're going to have 1x, and this is what? 0 equal to 12. And this is the same as, remember, x equal to 12. Sometimes it's easier to make a 1 first or make a 0 first. Choose what makes the solution easier for you to find, okay? Just, I need you to know that either one will get you to the answer, okay? Let's look at some different forms of ax plus b equals to c, where a, b, and c are elements of the real numbers. So 1/2 of x plus 5 is equal to 11. This is the same as 5 plus 1/2 equal to 11. As this one. What did we apply here? The commutative property. Okay? If I say 11 is equal to 1/2 x plus 5, that's what? That's the definition of equality. And if I say 11 is equal to 5 plus 1/2 x, that's the definition of equality and commutative. Okay? So we have, I could use this part of the page. So we have, if we like the form ax plus b equals to c, then we just write it in that form. Okay? But we need to be careful because, let me give you an example. 3 minus 2x equals to 6. When we rewrite this, we say 3 plus negative 2x equal to 6, right? So it becomes negative 2x plus 3 equals to 6. Ax plus b equals to c, right? So 3 minus 2x equals to 6 becomes negative 2x plus 3 equals to 6, okay? So this one becomes this one. There are some exercises, linear equations right here. And you can see it in the handouts. It will be the linear equation. The first one, x minus 3 equals to 3. X minus 7. So they want us to identify if we need to multiply, add, or both. They want us to identify the inverse element needed. And we need to check our solution. So first, what do we need to do? We need to do the addition, right? And we're gonna make a 0. So what we need to do is we're adding 7 on both sides of the equation. And what do I get? 10. So that's addition. And I'm making a what? Make a 0. And I know that 10 minus 7 is 3. Let's do another one. 5 over 6x is equal to 15. So I need to make a 1, right? And how do I make that 1? I need to multiply it by the reciprocal. And what's the reciprocal? 6 over 5. Right here, make a 1. And you're going to do it on both sides of the equation, the same number. So it's going to be x is equal to 3 times 6. This is 18. Remember, this part, you're going to simplify. Divided by 5 is 1, by 5 is 3. So what do I have left? 3 times 5, which is 18. All right? Now, the next one. Negative x equals to 6. So we know we have a 1 here. We're going to need to multiply by the reciprocal, right? Okay. So what's the reciprocal of negative 1? We're going to multiply by negative 1 over 1. Okay. And that's going to be done on both sides of the equation. So I'm making a 1. I'm multiplying. So x is equal to negative 6. All right. Now, three x minus 8 equal to 7. I need to do addition and multiplication. So I need to make a 0 and make a 1. Doesn't matter the order again. So let me make the 0 first. Right here, you're making a 0. So it's 3x equals to 15, right? Now, what are we doing? We're going to make a 1. We're multiplying by the reciprocal on both sides of the equation. So what do I have here? X. And over here, 5. I'm making a 1. Okay. And I have one more that we could do here. 5. We have negative 3/4 x plus 2 divided by 5/4. Okay? We could do make a 1 or make a 0 first. This one, what do we do? First, we make a 0. And then we make a 1. We could have done it the other way. So, this one, let's make a 1. And then we make the 0. So what do? We're going to have to, in order to make this the 1, we're going to have to multiply it by the reciprocal, which is 4/3 on both sides of the equation. Remember, you could have done it the other way. You could have made a 0 first and then make a 1. So if we're going to distribute this here, what do we get? We just get the x. And if I multiplied, hold on, let me do it. 4 times 3 times -4 plus -4/3 times 2. And what do I get here? This is a 1, so it's going to be -5/3. This is what? I'm making a make a 1. 4 times 2 would be -8/3 equals to -5/3. Now what do? I'm going to make a 0 by adding 8/3. Okay, so it's going to be x is equal to what? -5 plus 8 is +3/3, and this is equal to 1. All right, that's for this part. Now, let's do reducing the linear equations. But according to what I just, 2.1 is use general strategies to linear equations and use a problem solving strategy. All of this is part of 2.2, okay? 2.1 and 2.2. Let me add this here. So we're going to be doing this and use a problem solving strategy, okay? So we did solving linear equations, and now we're going to do reducing. We're going to study reducing linear equations. Okay, so we're going to reduce every linear equation in one variable. to the form ax plus b equals to c. There are several ways this kind of equation can be complicated. So we're going to be looking at three most common ways. So we are going to reduce every linear equation in one variable to the form ax plus b equals to c. All right? And we will look at three most common ways. All right? Now, number one. Let's do the first one. When we have variables on both sides of the equation, variables are on both sides. Okay? Let's do it. So, first, we're gonna happen we're gonna come up with a number that is less than 5. And we're gonna define x to be that number. So let's say x is equal to 4. All right? Now, so our first number is 4. And our second number is going to be 7. We're just picking numbers. This one was from 1 to 5, and this one was from 5 to 10. Now, let's build an equation. We could say that x plus 3 is equal to 7, right? If I add 3 to 4, I get 7. Or I could do, if I multiplied and I subtract 1, I get 7. And let's check that. So if x is 4 plus 3, it's 7. 7 is equal to 7. This is good. Now, 2 replace it with x replace it with 3. So this is going to be 6 minus 1 is 7. Hold on. Ah, 4, sorry. I'm still thinking about the x equal to 3. Okay, so let's do 8. 8 minus 1 is 7. So it's working, right? This means that x plus 3 and 2x minus 1 are doing the same job. They're both turning up. They're both turning up 4 into a 7. Both equations. So it was x plus 3 is the same as 2x minus 1. Notice that the equation has variables on both sides. So how are we gonna get down to what? Remember what we said? AX plus B equal to what? To 0 plus C? In the physical world, when we collect objects, we're doing the action associated with the addition. So we're gonna set up the equation here, and let's see the form that we want. Right here, this means we need to make a what? We need to make a 0. And how do I make that 0? Let's do it. So we have 2x minus 1 . Oh, you know what? I was supposed to, hold on. I can still change it. Give me a second. So this is going to have to be 2x minus 1 is equal to x plus 3. Okay? So I need to make a 0 here. So how do I do that? I'm just going to subtract x on both sides of the equation. And what did I get? X minus 1 is equal to 3. So now it's in the form of what? So this is now in the form of ax plus b equals to c. Know how to do it from here, how to take it from here. Now, the other common way, we did variables are on both sides of the equation. Let's do the other one. The other one says when we have parentheses are involved. So when that happens, we have 3x plus 2 equals to 10. So what do? I need to apply the distributive property. So it's going to be 3 times x plus 3 times 2 equals to 10. So 3x plus 6 equals to 10. And what do? We distribute. Okay. And the last one is what is called the uncombined terms. That are on both sides. So let me just give you an example here. It will be 3x plus 1 plus 2 equals 10 plus 2. So what do I need to do? Just combine the like terms. This will be 3 and this will be 12. Like terms. So after these steps are performed, all of the linear equations in one variable are reduced to the form ax plus b equals to c. And let me write that down. After these steps are performed, all of the linear equations are reduced to the form what? Ax plus b equals to c. All right? I do have some exercises that I could do a couple of those. And again, it's on your I can even upload the answers. I have them here. So you know what? I will upload the answers and you guys try them and let me know how it goes. All right? This is it for lesson 2.1 and 2.2.